Yes, class. So we have to start with rolling motion. This is the last part of your rotational motion. Then we'll start with gravitation in today's class only. But let us complete rolling motion first. This is not a very lengthy topic because see, rolling motion is basically, you have studied translational motion till your laws of motion, right? Not even laws of motion in your first and second lessons. That is your kinematics. Because in laws of motion, it was just add-on, right? We were talking about forces, then work came, then energy came, then power came, like this. So it is made up of translations plus rotations. Translations plus rotations, that is what is meant by rolling motion. When translation combines with rotation, it gives you rolling motion, right? See, when we talk about translation means something that is moving forward, just forward, and no other component is present. If I talk about, for example, when we walk, we just move in a straight path. We are just translating. It's the linear displacement that is occurring. So that is translation. When we talk about rotation, throughout we talked about moment of inertia, axis was present. So rotation occurs around an axis. One axis is definite, like Earth rotates around its axis. Fan rotates around its axis. Fan is a very good example. But when you combine translation and rotation altogether, when we were walking on ground, when we are walking on ground, that was just an example of translation. No other component got added, right? When you are just walking, that is a good example that you are translating, you are moving. Yes, Alia, is it audible? Harsha, you are able to see the screen? Harsha?
Yes, ma'am.
Okay. See, so translation is there, rotation is something that is occurring around a fixed axis. So have you ever seen a fan translating? Fan just rotates, right, around its axis. It just keeps on rotating. Within its axis, it rotates. The fan does not move within the ceiling, right? Rolling is translation plus rotation. Best example is the wheels, the tires of car. See, tires are rotating around their central axis also, as well as they are moving further. Car is moving because they are translating, right? And rotation is also occurring. That is combined rolling motion. Now, again, this system, we are talking about system of particles in this entire lesson. Throughout this lesson, we are talking about system of particles. So how will you represent it? How will you represent the system of particles? In translation motion also, there were lots of particles present. So what we do, we choose 3 points. 1 point above, 1 point at the center, 1 point below. There has to be center of masses velocity over this point also, right? There will be a center of masses velocity here also, as well as a center of masses velocity here. So 3 different points we have taken, right? So this is all about translation. This is the velocity of center of mass that is occurring. Coming to rotation, O is a fixed rigid axis. Let's say R is the radius. At O is the axis. Is the radius. So like this, rotation occurs with certain velocity, rotation occurs. So when we talk about here, this velocity, remember tangential velocity. Tangential velocity, can anyone tell me the formula of tangential velocity? Velocity was tangent. This, I hope you people are remembering it. This is velocity of center of mass, which is translating. You have studied this. We have studied the center of mass is velocity. This was what you have studied in this lesson. In the previous lesson, when laws of motion ended, when we were doing circular motion, that time we did this.
R alpha.
R
Alpha.
omega, not alpha, R omega. V is equal to R omega. Alpha was for acceleration. Okay, so good. You remember this. This is R omega. And similarly, at this point also, velocity will be tangential. Velocity is acting backwards. Then only it is able to rotate. This is r omega. Fine. This is r omega. This is v is equal to r omega at this point, tangent, and at this point. But when we talk about rotation motion, this is actually the tangential velocity. When we talk about rolling motion, there is velocity of center of mass also occurring, right? And because of rotation, r omega is also present. So how do you conclude at a point if I am asking you velocity, if I am asking you at a point, then in rolling motion, if you notice a point, this is VCM also and r omega also acting in the same direction. Please understand this carefully because the questions are based upon this, and this is the only theory part that we have. VCM is occurring in the same direction with the tangential velocity. So velocity at a point will be VCM plus r omega. But when we talk about velocity at this B point, can you notice velocity? This is occurring towards the right, this is occurring towards the left. So this will be VCM minus r omega because the directions are opposite. All right. Same thing happens in acceleration also. This is when I'm talking about velocity. VCM is velocity of center of mass. Same thing occurs in acceleration also. But acceleration I'll talk later. First note down this. See, then coming to acceleration in rolling. So when we talk about acceleration in rolling, again, acceleration of center of mass, we'll talk about same thing. Acceleration of center of mass in translation. And again, rotation. There will be an axis at the center. Centripetal acceleration will be directed towards the center along the radius. But tangential acceleration, this is the formula which you were mentioning, Harsha, alpha. All right, tangential acceleration. This is tangential acceleration. And here also this will be alpha r. So when we are talking about the rolling motion, again radius r is there. This is rolling, alpha acceleration, alpha is also there, means tangential acceleration is also there, and acceleration due to center of mass is there. Basically combined motion. So what is the net acceleration? Acceleration of center of mass will be counted, alpha r will be counted, plus here a centripetal acceleration will be also counted. Then you have the concept of pure rolling. Write down acceleration in rolling first, then we'll discuss pure rolling. Done?
Yes, ma'am.
Okay. Coming to pure rolling. See, pure rolling motion basically means the amount of translation that has occurred. For example, this distance that is covered, the tire has started moving and the tire has reached this point and this distance is 5 meters. When the rotation occurs, means this distance, that is the 2 pi r distance, the periphery of the tire which is touching the road, this circular rotation that is occurring, that is also 5 meters. So that becomes translation distance and rotation is over. That is a case of pure rolling motion. For example, they're saying a car moving on a concrete road, translation motion is equal to rotational motion. So you can take this example. These are the reference points. Suppose the tire has reached this point. This distance is 5 meters and this is also 5 meters. That is distance covered in translation is equal to distance covered in rotation. Now see, remember two types of cases which occur when one component can be greater. See, it can happen that rotation is greater than translation. When if tire is stuck in sand, so there is no translation occurring, tire is just rotating, right? So this is an example when the rotation component is greater. So if tire is stuck in sand, car then needs more acceleration to move. So it's the rotation component greater. Or second case, see, this is the first case. Second case can be when the translation component is greater than the rotation component. See, on very slippery road, when friction reduces, or on circular tracks, when the centripetal force is lesser to be balanced, then the tire slides, car skids. When the safety limit is also crossed, then also the car skid. So when the tire slides, during that time, rotation component decreases, translation component increases. So if tire, in such case, translation component will be greater than the rotation component. So it can be variable, but if both the components are exactly the same, that is the case of pure rolling motion. This proper displacement covered is equal to the proper rotation motion occur. For example, let's start. This is point A, radius is R. This part, CM is the center of mass. Here, velocity will be occurring at this point, velocity at A point. Let's say the tire has completely moved and reached this point. Tire has first reached this point, that is A point, like this. It has moved, so A point has reached over here. A certain distance is covered over here. Then it again rotated, and this A point is again reached back. So how much is this separation if this is a case of pure rolling? This is exactly equal to 2 pi r here. If this is equal to 2 pi r, then only this is the case of pure rolling. Otherwise, you know which component is more, how to identify which component is more, that also you can do. So velocity of center of mass. Velocity is distance covered by time. Distance is 2 pi r divided by time. Let's write times formula in terms of angular frequency. Omega is 2 pi by t. So t is 2 pi by omega. Put this value here. So velocity of center of mass, this will become 2 pi r divided by 2 pi by omega. Pi will get cancelled, 2 will get cancelled. See, velocity of center of mass, this is again coming r omega. So this is only for pure rolling. You see, this is only valid. This formula, this is a separate formula which you can derive it. This is coming similar to the velocity that we were seeing earlier also. Only valid for pure rolling. This is only valid for pure rolling. All right. Now, just in case these 3 points we were considering at the extremes, what if it is in the middle? Suppose this is in the middle. This is a point. I have taken a C point here. O, A point was already here, B point, this is, I have taken a C point. This is at a separation R by 2. Then see here, for this point, you will take omega R by 2 instead. Clear? So when we talk about velocity, one center of mass velocity is already there, right? Because radius doesn't involve in your center of mass. So what is the net velocity? It will be velocity of center of mass plus omega r we used to write, that will become omega r by 2. So depending upon the radius, you can fluctuate this radius as well. Last topic that is left before practicing the questions is kinetic energy. Note down pure rolling first, then we'll discuss kinetic energy.
it's written there only valid for pure what?
Yes, yes,
Yeah,
Martin.
only valid for pure rolling. Is that it?
Yes, yes, this is only valid for pure rolling means this formula that I have written VCM is equal to R omega. See, when we were discussing this part, that time also V is equal to R omega came and VCM came. But these two were never equal. V was equal to R omega. That was the tangential velocity. This is center of mass is this time equal to R omega. So this is not valid for any other case. This is valid only for pure omega. Otherwise, these two are different velocities. Right now, the tangential velocity is equal to center of mass's velocity. This is what is meant. Okay. Now coming to kinetic energy in rolling. So again, when we talk about kinetic energy in rolling, it is combination of kinetic energy in rotation and kinetic energy in translation. So this is the formula will become kinetic energy in rolling. This will become what is kinetic energy in rotation? Half I omega square. And what is kinetic energy in translation? Half velocity of center of mass square. So the total formula that you have to study is this only. This is the total equation. But see, we'll be discussing some more things because sometimes in different questions, these are used, right? So let us elaborate velocity of center of mass. So see, or let us just elaborate moment of inertia. Center of mass is velocity. You can calculate it. This becomes half m VCM square. When it comes to I omega, you can write this as m r square, or let's write it as k. Let's write it in terms of moment radius of gyration, because no, in most of the questions, radius of gyration will be given to you. So mk square omega square, right? I is equal to mk square. This was the last topic at which we stopped the class. Let's do one thing. Mass and half we can take off. Yes. So kinetic energy will be half into mass. This becomes VCM square plus k square omega square. Yes. Now, if it's the case of pure rolling, then what we have studied right now, velocity of center of mass is equal to r omega. So omega from here will be equal to VCM divided by r. So omega square will be equal to VCM square by r square. Put this here. Put this in this equation. So this becomes kinetic energy of pure rolling. This becomes m by 2 VCM square plus k square VCM square by r square. Or further we can take, let's take VCM square common only. Because now VCM square can also be taken common. No? So this is VCM square, half m VCM square, 1 plus k square by r square. This is the formula for pure rolling. Right? Note it down. Let us practice 1 or 2 questions. This is the entire theory part of rolling motion. Small topic, not very difficult to understand. This is clear to all of you. Harsha, Alia, Martin, clear? Yes or no?
Yeah.
Okay. Note it down. Then 2 questions we have. 1 question only we'll practice. 1 question. That will be a summary of all the questions.
Ma'am, if it's not pure rolling, then which formula do we use?
Yes, yes, Harsha, what you saying?
Ma'am, if it's not pure rolling, then which formula do we use?
If it's not pure rolling, then you will simply use this one. If it's not pure rolling, or you can even involve radius of gyration, but substitution from this step will not be valid then, right? We are substituting this step for pure rolling. Yes, VCM is equal to R omega. From there, we calculated the value of omega. Then till here, your answers are valid. If it's not a case of pure rolling, if it's mixed rolling. See class, here no, actually a concept of your work energy and power will be utilized. A disk, a solid sphere, a solid cylinder are released from the top of inclined plane. Compare their velocities at the body. All the bodies have same mass and radius. Basically, you will be using conservation of energy. Conservation of energy. So from the highest point, potential energy will be converted into kinetic energy. Potential energy will be mgh, height is h, gravitational forces acting downwards, m is the mass of both the bodies that we have assumed. And then we talk about kinetic energy. So this is a pure rolling case, right? Whatever distance is covered, and obviously it's a smooth surface that is given inclined plane. So usually at inclined plane, you have to, this is case of pure rolling. How do you identify that it's a case of pure rolling or not? See, when nothing is mentioned, by default, that becomes a pure rolling case. Okay, if nothing is mentioned to you, know, like nothing was mentioned, that this the translation is more or rotation is more. Because in your syllabus, you have pure rolling. So you will assume by yourself that pure rolling is given because nothing details are mentioned. If there are any specific, then that will be mentioned, but most of the questions are based on pure rolling. So 1 plus k square by r square is valid. Mass will be cancelled as we had no clue of the mass also. So velocity of center of mass will become 2gh by 1 plus k square by r square under root. All right. So disk is equal to r by root 2. When you will put in the all the values, no, you will find out that k is what? R by root 2. Yes, radius of gyration. So for disk, you will substitute r by root 2 here. For sphere, you will substitute solid sphere, you will substitute r root 2 by 5. And for cylinder, you will substitute r by root 2. So for that, you will check the velocities, compare the velocities, which is greater, which is less. This at least you all should do. Though, okay, let me discuss it then. See, this is how you will do 2gh, you will put it 1 plus c k square. So this becomes r square by 2 divided by r square. We'll just have a look at the denominator. Then VCM is equal to c. Like let me solve this one. The rest of this you can do it. This becomes 2gh. This is 1 plus half, that is 3 by 2. So velocity of center of mass for disk and cylinder, you can notice that this is the same. So this becomes 4gh divided by 3 under root 4gh divided by 3. Now you will put then k square, this will become r square, 2r square by 5, just a second. This becomes 2r square by 5, right? K square is equal to 2r square by 5. So here you will substitute 2r square by 5, again r will be cancelled, 5 will go up, 5 into 2, that will become 10. This is how you have to analyze. So disk and cylinder will be the same. You have to choose among these two, disk or cylinder and solid sphere. That you can solve by yourself. Let me know what's the answer coming, but you will use this basic formula. Note it down. Let us have an introduction of gravitation also. Still we have time right now.
Ma'am, in the first case, how did we get r square by 2r square?
Yes, Harsha?
Ma'am, in the first case, how did we get r square by 2r square?
R square by 2r square in this manner, that this is k square. So square this, you have r square by 2, and this 2r square was already there. So r square by 2. R square. Got it?
Yes, ma'am.
I would suggest, Harsha, some of the values you should memorize. You should remember certain values. That will be helpful for the questions, because these types of questions are only there in your rolling, in your rotation. So that saves time, because then from where will you start? Suppose this type of question comes, then you will start I is equal to mk square. The moment of inertia for disk is mr square by 2. Mr square by 2 is equal to mk square. So you are getting r by root 2. Then you are squaring it, then putting it. So it's better few figures: disk, cylinder, sphere, and ring. This you should remember. That's a suggestion. Otherwise, it will be beneficial only for you.
For the cylinder, is it r by under root 2?
Cylinder, if it's a solid cylinder, it would be r by root 2. No? These are all the
Okay.
solid figures. Solid sphere, solid cylinder. Solid cylinder's formula was similar to disk, no? So these are all the solid. Had it been hollow, then it would have been similar to mr square. Yes, class, gravitation. So gravitation is chapter 8, right? Now see, gravitation chapter is very important because gravitation, all the concepts of gravitation that you will be studying in class 11, you will be having similar concepts in your class 12th first lesson, first unit of your class 12th. So soon you will be going into class 12th. So there you have electrostatics. Whatever we'll be talking about masses over here, that time you'll be talking about charges over there. So it's a strong connection that you will notice. So if you study here properly, no, understanding that time is easier. You'll be able to relate it also. So it's like just study it one time sincerely, then that would be fruitful for a more longer duration. So basically this lesson is divided into Newton's laws of gravitation and then Einstein's theory of gravity. Moreover, Newton's laws of gravitations are very important. Then we'll again have potential energy, gravitational potential energy. Then all these concepts, see, gravitational force, gravitational potential energy, this will become electric potential energy, electric force and all. So please pay attention over here. This is a very easy lesson, I'll tell you. It's not a very difficult lesson. Just step by step, if you follow formulas, lesson is also small. This lesson is not a lengthy lesson. You can get very tricky questions from rotational motion class because you have seen how many forces are acting at a particular time. Tangential velocity is also acting, so tangential acceleration is there, but you never know when centripetal acceleration comes into action. Sometimes you miss on that, sometimes you miss centrifugal force, sometimes centripetal force is there. So rotational is actually a tough lesson. Though I have tried to simplify it for you by bits and pieces. We have studied it, and circular motion also we have studied it separately. But if you study it all together, no. Why rotation is a difficult lesson? Because from your motion in a straight line, all the concepts can come in a one single question. Vehicle is moving, starting with this velocity, acceleration is there, retardation is there, then force will also come, then what is the work done? And what is the work done in rotating the particle? Like this, a question will come. So you have to apply all the concepts. Here in gravitation, at least this is a completely new concept for you. Formulas are also easy. Derivation is also easy, and the best part is that this lesson at least has good amount of derivations. You know, derivation saves your time because you remember it, you learn it, you just write it in your exams and you get good marks. And derivation questions are also not of small marks. What you have to do, you just have to remember the first line in your derivation. So pay attention in this lesson. Your first book should be ready by now. Okay, see, gravitation will complete. Gravitation will not take so much of classes. Variations due to gravity, and this is interesting also in comparison to the other lessons of mechanics. This is interesting also. Now you will be, from now onwards, no, you have different types of lessons. All the boring and similar one type of part of mechanics is over. That was one single unit. If you see, we have continuously been studying the same thing all over. Vehicle is moving, car is moving, object is dropping, velocity is acting, acceleration, and all and all and all. Here also you will have acceleration due to gravity. Here also you will be applying velocity. Here also sometimes you will be using uniformly accelerated motion. But apart from there are other concepts also to study, different concepts that you have to apply, new formulas that you have to remember. So that's why I'm saying I'm giving you an overview. Like as a student, I'm telling you, as a student, this lesson, to study this lesson is not difficult. It's easy. It's a small lesson. During revision also, this will not take time. Now onwards, all the lessons have different concepts. Now your bulk properties will start. Fluids will take a lot of time. Fluids, in a very short lesson. Solids, this is different. Then you'll have thermal physics and oscillation waves. All these are now different topics. So please keep on revising your mechanics all over. What is the law of Newton's gravitation? This is very important, class. You have Coulomb's law in your electrostatics in class 12. Same thing with the help of charges and the difference in constant. So pay attention, class. Try to just know, even at the last, when you're before starting your class 12th, when you will have the session gap, right, after your annual exams, try to revise gravitation. It will be helpful for you. So basically Newton's law of gravitation says that if two masses are present in nature, gravitation, do not always think that gravitation lesson we are studying, so we will be talking about space only. Two masses means two masses on earth, anywhere two masses. You know, gravity is acting everywhere. So it's not that only you will be talking about planets and space and gravitation. No, we'll be talking about we'll be talking about the planets also. These two can be mass, this can be earth and sun, this can be they can be any two planets, right? So first it says that the Newton's law of gravitation says that the magnitude of this gravitational force is proportional to two things. Firstly, product of the masses. It is directly proportional to the product of masses, that is m1 multiplied to m2. Directly proportional to the product of masses, m1 into m2. Secondly, both the masses are separated by a certain separation, r, let's say, right? Two masses are separated. It is inversely proportional to the square of this separation. This is inversely proportional to the square of distance between them. Inversely proportional to the square of distance between. So altogether, what is the gravitational force proportional to? It's a very important formula. It's directly proportional to m1, m2, inversely proportional to r square. How do you remove the constant sign? You put a proportionality sign. So gravitational force is equal to capital G is the constant that comes. Capital G is the constant that comes. m1, m2 by r squared. This is the formula. G is the universal gravitational constant. Universal gravitation constant. This value all of you should remember after this class. Any day, anytime I'll ask you. Firstly, and secondly, without this value, entire gravitation you'll not be able to do. So if you are not able to learn this one simple value of gravitational constant, then just skip this lesson. It's better if you skip this lesson, your syllabus will also be reduced and you'll be able to focus on other lessons. Because without this value, you'll not be able to solve and attempt the questions of this lesson. So I am telling you, revise this value and come in the next class. This value is 6.67 into 10 to the power minus 11 Newton meter square per kg square. For a second, you can forget the units also, because units from the formula you will be able to derive. But this value, you will have no option in the exam. And this is independent of medium. That's why this is called universal gravitational constant. This is a universal law. Universal law means, see, if I talk about Earth and Mars, both the planets are present in the vicinity of each other. Or let's talk about Earth and the moon of Earth. Both are also present in proximity of each other. So it is valid for moon and Earth. This law is valid for Earth and Mars. And this is even valid for the pen and pencil, for the pen and the notebook that you're holding. They are also two masses that are present and they are also exerting gravitational force to each other. So it's so universal that it's so close to you and it's so far away there and still valid. Universal law. Very few laws are universal. Most of the things change. Like I told you, an example, Coulomb's law you will be studying in your class 12. There you will study about charges. So charges will be depending upon the medium. If you put two charges in air, something with the value of force will be different. If you dip the two charges in oil, value of force will be different. You know how attraction and repulsion occurs. At least this much you already are aware of in class 11. But this law is valid throughout. any two particles, any two substances which are present, they are able to exert gravitational force. And the same value of G is applicable anywhere, in vacuum, in oil, in glass, in copper, in any medium or in air. So this is independent of medium, and this law is itself a universal law. All right. So what is the gravitational law? F is equal to G m1 m2 by r square. This gravitational law is valid only for point masses or spherical bodies. Yes, this you should remember. See, when we talk about, when we are solving this law, this is actually a similarity to the law you'll be studying in 12th also. Point masses means that we, again, system of particles and rotation. Remember, that's why we did this lesson before. This is a sequence. That's why these lessons are given in NCERT. Point masses means your center of mass or the point mass that is present, because there are system of particle. Every particle will be exerting every force. So you cannot consider any other. Every particle you cannot consider. So you talk about the point masses. Or if it's a sphere, then it's completely valid. Two spheres are present. That's why I'm taking the example of planets continuously, because they are spherical. Though we know what is the exact shape, but in general, for our calculations, we assume that those to be perfect spheres. And gravitational force is a conservative force. Conservative force, I have discussed it so much. And when I was discussing conservative force, that time also I was giving you the example of gravitational force. Independent of the path, just depend upon the initial and final point. It doesn't matter what is the entire path that is covered. Revise conservative force, all those who have forgotten. Write it down. Make from a fresh page. ऐसा नहीं होना चाहिए from where you have left the last portion of rolling motion and a space is left, you're starting the new lesson from there. From a fresh page, chapter 8, gravitation, 1, 2, Newton's law of gravitation, write it like this.
And can you go up? Yeah, ma'am, you can go down.
completed class. You people can leave because we'll continue now gravitation in the next class. Okay. Thank you so much, class.
Thank you, ma'am.